So hello everyone, in this video we will see how we can calculate AIC and BIC value. Okay, AIC is AIC information criteria and BIC is Bayesian information criteria. So it is a statistical matrix used to compare the relative quality of the model. There are various processes where we use the model to predict or to know the kinetics of that process, like there are microbial inactivation, drying kinetics, extraction kinetics, enzyme inactivation and degradation kinetics. To know the behavior or to predict the behavior of this process, we use the modeling. So there are number of models we use to see the behavior of this process. Suppose there is a drying kinetics and there are 4-5 models we use to see the particular drying process. Among them, one will show the best drying process. Also we use some statistical parameter like R square, chi square, RMSE. These are the statistical parameter to know the which model is best. But there is a problem with this model that sometimes it get overfitted or underfitted. Among them, which model is best, we use this AIC BIC value to the best model will be which has the lower AIC and BIC value. If the AIC BIC value will be higher, the model is more likely to be rejected. Coming to the next, AIC is calculated by the following formula, where AIC equals to 2k minus 2 ln natural log L, and BIC is calculated using this formula, k into natural log n minus 2 natural log L, where this k term is the number of parameters in the model and L is the maximum likelihood of the model and n is the number of data points of that particular experiment. If this k and n value will increase, that means the number of parameters of the particular model will increase. That will the model will get more complex. So that's why these terms are called as penalty for model complexity. That means the complex model will give higher value and that will lead to increase in the AIC and BIC value, and that will help us to reject those particular model. At the same time, these L terms is called as the maximum log likelihood, and this will give which model is best to predict particular behavior. So here we know the number of parameter of any model, we know the number of data point of that experiment. Only thing we need to calculate is this L value. So how to compute log likelihood? So there are various formula you may see in the value of L. So assuming the Gaussian factor, this is the simplest formula that you can see here, where the natural log L is equal to minus n by 2, and this is a constant term, natural log of 2 pi plus natural log sigma square plus 1, where this sigma square term is calculated by RSS divided by n, residual sum of square, and it is calculated by the actual minus predicted value to the square and their summation, and divided by the number of experimental data. So after calculating this, we can calculate the AIC and BIC value. And before calculating the AIC BIC value, we need to also understand what is overfit and underfit. Let's suppose we have our experimental data like this, and if we use some simple model like linear model, in that case it has only one parameter and it will lead us to underfit, because our data point is like this and it has only one parameter, it cannot fit it completely. This will lead to underfit. At the same time, if we use non-linear model where the parameters can be 2 or 3, so it will give a good fit to our data points. So this will give us, this particular kind of model will give good fit. And the next time, if we have a few points like this, and this may be due to like noise or some certain random fluctuation during our experiment or during noting data, so this may happen. And then if we use some complex model and it has a number of parameter will be the more, in that case also it will fit our data, so that will be called as a overfit. So here we can see the problem that if we use model, complex model like this, it has fitted data. In this case we will get R square very high, RMSE very low, so we will say that this model is very good, but at the same time we can see the problem behind this. But this will, AIC and BIC value will help us to come out with this kind of problem, like the complexity will be more, so AIC value will be more, and that will tell us this, that this kind of model is overfitted. Let's go to the Excel and we will see that how we can compute AIC and BIC value. So here we are. Here we can see this is one experiment was done, and then here we have actual data and this one is predicted data, and these are done for a model we have chosen to predict this kind of, to predict this behavior. First thing, we need to calculate the residual, and for each terms I have given the formula over here. You can use this formula to evaluate the terms. First we need to calculate the residual. For residual we need to minus the actual, and this one is the predicted by the model, so we will subtract this value, so equals to this value minus predicted value. So we got the residual value. We will just drag it down for everyone. Next term we need to calculate the power of residue, so equals to residue to the power. So we got these terms. So the next thing is that we need to calculate the RSS. So RSS is this is the residual, and square we have already done, and summation of that we will sum all the value of particular model, so up to this point. So we got this value. Just like that we will calculate for first order, and then we will calculate for power model, and we will calculate for second order, as we can see. Okay, so number of data point of this experiment has the 5, so we will divide the RSS with the 5, and we will do this for every model. After getting this value, next thing we need to calculate the value of this constant term. So we will just put the formula ln and 2 into 3.14, that is a value of, and we will copy paste for, it is done for every model. Next thing is to calculate this one. Okay, so this value was called as a sigma square, so we know this value, so we just take the natural log of this particular value, so we will got the ln sigma square. So ln this value, and we will do this for this one. I'm just pasting the formula so it automatically evaluate for all. Okay, and next thing is we need to do the n by 2. N is our 5 number of data point, so 5 by 2 is 2.5. okay, so after evaluating this, now we got the n by 2 value, this value, we will calculate this one, so equals to minus n by 2, and then bracket, we need to sum this value. So first ln 2 pi plus this value plus 1 and close the bracket. Okay, here we need to do the multiplication sign. Okay, so we got the natural log value, and then we will calculate for a remaining as well. The only left is k value, and the k is number of parameter. For each model only 2 parameter is there, you can check it. So I simply put it 2 into 2, 4 over here. So we got all the value for calculating AIC value, but for BIC value k is there, everything is there, only thing is natural log n is missing. So natural log n we have to calculate, and the value of n is 5, that is the number of data point. Okay, now we are ready to calculate the AIC and BIC value. Let's see. Here we will calculate AIC, and here we will calculate BIC value. Okay, so AIC is formula of 2k, that is this value minus 2 into this value. So 2 into this value. So we got 19.144. We'll copy this one, we'll paste over here, we'll paste over here, we'll paste over here. So we got the AIC value for all 4 model. At the same time we will calculate the BIC value. We'll press the equals to k into natural log n, where k value is 2 into natural log n, this value, minus 2 into natural log l, so this value, and this will give the our BIC value. Okay, so we have calculated our AIC and we have calculated our BIC value. So we can calculate the AIC and BIC value using Origin software as well, where we do the model fitting. In the next video we will see how we can calculate the AIC and BIC value using Origin software. While calculating AIC BIC value, the Origin will give the different value as we have calculated here. Because of this L formula, what the software uses we don't know, but the trend will be same. What I mean say that the model which has got the lowest AIC value will be the same for the Origin software also. So in the next video we will see that, and we will compare this data with their data. For now we have seen that how we can calculate AIC and BIC value manually. Thank you so much.